Today's lecture is over Chapter 1, Section 2. Section 2 objectives. Number 1, compare the advantages and disadvantages of maps and globes and identify 3 types of maps. Number 2, describe how geographers use satellites and other tools. So we start off today talking about maps and globes. And what we're going to see is that the oldest known maps are going to be the Babylonian clay tablets about 500 BC. Maps show location, places, landform, and bodies, and these are all things that usually people understand about them. What we have is that we got 2 different types of dimensions. We've got 2-dimensional globes and we have 3-dimensional globes. Really, a 3-dimensional globe is, we call it a globe, of course, and what it does is it shows the Earth. We also have a map, and a map is a 2-dimensional graphic that represents the Earth's surface. Now, one thing that we have to look at is that a cartographer tries to accurately reflect the Earth's surface, and they do this by doing what's known as a map projection. A map projection is a way of showing the Earth's surface that's curved on a flat map. Now, the thing is that a lot of people look, and this is an example right here of Google Earth and Google Maps, but what we see right here is that we see that we can go ahead and we can take a satellite image, we can take a map image, whatever the case may be, and we can go ahead and we can create our maps right here. But one thing that we've got to look at, and a good example, I'm going to try to show this to you, is that Greenland is a great example of the fact that we cannot make a round object flat without creating distortions. If you look at Greenland right here, Greenland is literally top to bottom of your screen right there. But when I look at the United States fits in nice and perfect. If you go look at a globe, what you'll see is that Greenland is much smaller than the United States. And so what we see is that this has been distorted. It's been pulled out. It's been moved around. It's been made to basically have a round object flat. Think of a balloon. If you blow up a balloon and then you go ahead and you try to make it flat, what you'll have is you'll have a bunch of wrinkles. Those wrinkles are distortions. And so cartographers do as much as they can to basically make that round object flat. Of course, it is impossible, but we can go ahead and get pretty good at some things. Now, there are 3 different types of maps. We have general reference maps, we have thematic maps, and we have navigational maps. Topographic map is one kind of reference map, and what we see is that a topographic map is going to show natural and man-made features on an Earth. So a topographic map, very easy, very simple. It's just going to show where things are. Now, the second thing is a thematic map, and this shows specific data such as climate and population density. So what we can look at, and I'll go ahead and I'll pull it up here. And so what we see here is that we're going to see this map, and this map is going to show 2 different things here. Number 1, it's going to go ahead and it's going to show the boundaries and the states right here. But what it also is going to show, it's going to show us who voted for whom in the 2006 presidential election. So what we see is the red states show which states voted for President Trump, and then we show the blue states show who voted for Hillary Clinton. So what we can see here, and if we go back to the thematic map definition, is it shows specific data. And so this right here shows exactly where all the boundaries are, but it also shows who basically, which states voted for which person. So that would be a thematic map. A navigational map would be used by sailors. This would be something that might be a little bit more specific. So if you're going to go ahead and you're Henry Hudson and you're going to North America, you're going to look at a map of just North America because you want to be able to see exactly where you're going. Now, the science of map making is a little bit more difficult than what people think it is. Surveyors observe, measure, record what they see in a specific area. You can go ahead and you can look at an aerial photograph, but you can also look at things like satellite imaging. So what we see here with the satellite imaging is that we can go ahead and we can look and we can see that all of these things really show exactly where things are at certain periods of time. Now again, the map is going to be distorted in some areas, but what we can see is we can see green vegetation, we can see darker areas that might be a little significant of deserts or mountains or things like that. So what we see is that these are going to include different things from different areas, and it shows exactly what they are. Now there are 3 types of maps: general reference map, thematic maps, and navigational maps. But what we look at is that that we look at general reference maps. Now, satellites, or best known satellites, are the Landsat and the GOES. If you go ahead and you look at Google Maps, what you're going to see is that at the very bottom of the screen, and I can't show this to you right now, but what you'll see at the very bottom of the screen is that you'll see that it actually is going to say Landsat, because that's what they're actually using. So this is going to be very, very common right here. Landsat, series of satellites that can scan an entire planet in 16 days. You see the geostationary operational environmental satellite, which is the GOES. The GOES orbits in sync with the Earth's rotation, and it can take pictures and basically go ahead and look at these atmospheric conditions and can predict and help predict weather. We also see the GIS, or the Geographic Information System, digital geographic database, which basically combines and displays information from a bunch of different resources. Then we also are going to go ahead and we're going to see GPS. This is what is in everybody's phones. Uses a series of 24 Navistar satellites to beam information to the Earth. Handheld GPS receivers on Earth display exact position, and again, this is where you can go ahead and you can use these. An example of this data layering, what we're looking at, is what we see is that they need to go ahead and they need to integrate the data. Reason is this, and I always ask students this question: if we were right now in the classroom, could the government be looking at us through different types of laser beams and things like that? And the answer is no, they can't, because we have the roof that's over top of us. So what do? What you do to get as much as possible and as accurate as possible is you might have the Google Maps people driving around and taking pictures from kind of the land area. And so you might see the street data. Then you might go ahead and you might take pictures of just specific areas, buildings, things like that. You might add in the vegetation here, and then we go ahead and we connect all these three and we make that integrated data right there. What that does is that allows us to have the best picture, and of course this is what allows us to go ahead and this allows us to zoom into Google Earth as much as possible. And again, what we can do is that we can go ahead and we can scan in from space here and see very, very specific things. We can go ahead and we can look, and at some point we can go ahead and we can get the street view, of course, which again, this is the integrated part that we may not be able to see because we might be going ahead and we might just be seeing the shrubs and things like that. So we've got to go ahead and we've got to connect all of these things to be able to make that integrated data. This completes Chapter 1, Section 2 of the notes. Please complete the assessments at this time.